All right, let's talk about one of the biggest, most mind-bending mysteries in all of physics. It's a discovery so completely off the charts, so utterly impossible, that when scientists found it, they could only give it one name: the oh my god particle. So picture this. It's a quiet night in 1991, and a detector out in the Utah desert called the Fly's Eye picks up a faint flash in the atmosphere. That flash was the calling card of a single, solitary subatomic particle that, according to everything we thought we knew about the universe, simply had no right to exist. This is where our cosmic crime scene begins. So what was so impossible about it? Well, it all comes down to this number right here: 320 exaelectron volts. Now, that's just a measure of energy, but to a physicist, seeing that number attached to a single particle it's genuinely shocking. Let me try to put this into perspective for you. Just look at the scale of this thing. The Large Hadron Collider is the most powerful machine humanity has ever built, right? It can slam particles together with about 0.015 eV of energy. This one single particle that fell out of the sky was 20 million times more powerful than that. Nature casually created something that completely dwarfs our species' greatest scientific achievement. Think about that for a second. The kinetic energy of a fastball, an object with real heft that you can feel, all concentrated into one invisible subatomic proton. That's like taking the power of a lightning bolt and cramming it onto the tip of a pin. The physics involved are just staggering. So let's properly investigate this thing. We've talked about its raw power, but to really get why it's so strange, you have to understand its absolutely ridiculous speed. I mean, just look at all those nines. This particle was moving at 99 point a whole bunch of nines% the speed of light. To put it another way, if you had a race between this particle and a beam of light across our entire galaxy, the light would only win by less than a quadrillionth of a second. It was practically touching the universe's ultimate speed limit. And this is where things get really weird, like straight up Einstein weird. For us here on Earth, this particle might have been traveling for millions of years. But from the particle's own point of view, thanks to time dilation, that whole epic journey would have felt like it was over in just a few minutes. At these speeds, time itself starts to break. And just one more time to really hammer home the energy scale here. A simple chemical reaction, a few electron volts. The mighty Large Hadron Collider, that gets us into the trillions. Awesome. But the oh my god particle, we're talking about quintillions of electron volts. This isn't just the next step on the ladder, it's on a completely different ladder, on a different planet. Okay, so this particle's power is amazing, but that's not the biggest mystery. The real head-scratcher is that its very existence seems to violate a fundamental rule of physics. It appears to have broken a kind of cosmic speed limit. To get this, you first have to know that empty space isn't really empty. It's filled with this very faint, cold radiation left over from the Big Bang. It's called the cosmic microwave background. You can think of it as a kind of universal fog that's everywhere. Now, this cosmic fog creates what physicists call the GZK limit. The idea is pretty simple. Any super high-energy particle flying through space is going to constantly slam into these tiny photons from the CMB. Every single one of those collisions acts like a tiny bit of friction, like a cosmic headwind that robs the particle of a little energy. The theory says that after about 160 million light-years, a particle should have lost so much energy that it's no longer ultra-high energy. And that brings us to the core of the mystery. This particle arrived with way too much energy to have traveled from some distant galaxy. It smashed right through the GZK limit. So what does that mean? Well, it means one of two things. Either it came from somewhere in our own cosmic backyard, or our understanding of physics is fundamentally wrong. Okay, so if this particle was fired like a bullet, we need to find the cosmic gun that fired it. Scientists traced its path backward across the sky, pointing to the spot it came from, and they found nothing. A completely empty patch of space. No obvious source. So let's look at the lineup of possible suspects. The prime suspect has always been an active galactic nucleus. These are the supermassive black holes at the hearts of galaxies, gobbling up stars and gas and shooting out these enormous jets of plasma. They're basically natural particle accelerators the size of solar systems. But even the math on these cosmic cannons struggles to produce a single particle with this much punch. All right, what about suspect number 2? Gamma ray bursts. We're talking about the most violent explosions we know of, the death cries of massive stars. They have the energy, no question, but they're also super brief and highly focused beams. The odds of one of these things going off and being aimed so perfectly that a single particle from it hits Earth, it's just astronomically, almost laughably unlikely. Suspect number 3 is a more recent idea: starburst galaxies. Think of these as cosmic mosh pits, just chaotic factories of exploding stars and tangled magnetic fields. The theory goes that a particle could get trapped in there, getting ping-ponged back and forth between magnetic fields, gaining energy with every bounce. And this one is a pretty tantalizing lead because modern observatories have actually found a hotspot of high-energy particles coming from the direction of a galaxy just like this. And then we have our fourth and most outlandish suspect: exotic physics. The idea here is, what if there was no gun? What if the particle wasn't fired from anything? What if it's the result of something totally new, like the decay of some undiscovered, super heavy dark matter particle? Or, and hang on for this one, what if it was born from a topological defect, a literal crack in the fabric of space-time itself? Yeah, this is where things get really wild. So after decades of hunting and all these potential suspects, where are we? The honest truth is, this cosmic cold case is still very much wide open. The search hasn't stopped, of course. We've found more of these cosmic bullets, like the Amaterasu particle just a few years ago. We've even built a gigantic 3,000 square kilometer observatory in Argentina just to hunt for them. And yet the trajectory of the original oh my god particle still points back to nothing, a void. The mystery is somehow even deeper now than it was in 1991. And this number really explains why it's so hard to solve. On average, a particle this energetic will hit any given square kilometer of Earth exactly once every 100 years. We're trying to solve a mystery where the clues literally arrive once in a lifetime. You know, in the end, the oh my god particle is really just a lesson in humility. It's a reminder that there are forces out there in the universe operating on scales that we can barely even imagine, let alone create ourselves. It's a messenger from a far more extreme and violent cosmos than we're used to. And that really leaves you with one final, kind of chilling thought. The OMG particle was just one proton that happened to hit our atmosphere in the right place at the right time. So you have to wonder, what else is silently streaking through the void, carrying secrets that could completely rewrite everything we think we know about the universe?